Good day, class. Today we'll be doing the Eliza testing. Eliza enzyme-linked immunosorbent assay, also known as enzyme immunoassay (EIA), is a biochemical technique used to detect the presence of an antibody or an antigen in a sample. So we have the principles. There is the direct antigen EIA. In these applications, we can do this on TSH, thyroid stimulating hormone, FSH, follicle stimulating hormone, LH, luteinizing hormone, and PSA, prostate specific antigen. So the specimens, calibration controls, and conjugate are mixed to form an immune complex which is bound to the surface of the wells by an immobilized antibody. Excess enzyme conjugate is washed out and a substrate is added. This renders a blue color to the reaction. The reaction is terminated by a stop solution. This turns the contents of the wells yellow. So in other words, it goes from blue to yellow, the intensity of which is directly proportional to the concentration of the analyte being measured. The concentration of the calibrators or standards is then used to construct a calibration curve. From this curve, all controls and patient samples are interpreted. Another principle, class, is competitive EIA. So this application is for T3 and T4. So part of the thyroid profile. Test specimen samples, calibrators, and controls conjugate are added to T3 or T4 coated wells. Competitive binding between the T3 or T4 in the test specimen and the T3 or T4 peroxidase conjugate takes place for positions on the coated wells. Unbound enzyme conjugate is washed out and a substrate is added. This renders a blue color to the reaction. The reaction is terminated by a stop solution. This turns the contents to yellow, the intensity of which is inversely proportional to the concentration of the analyte being measured. The concentration of the calibration standards is then used to construct a calibration curve. From this curve, all controls and patient samples are interpreted. Specimen collection and handling. Depending on the test kit used, whole blood, serum, or plasma samples may be required. Collect whole blood samples and process accordingly. Frozen serum samples must be brought to room temperature and visually examined for particulate matter before testing. In this procedure, class, we have to use a particular well. This is the holder. And this is the actual strip in which we'll be doing the actual testing. So these strips are coated with, it will be specific to the test that you're doing. So what we're doing today is the FSH. So in FSH is the direct method. So it's coated with what the wells are coated, and I'm going to also demonstrate to you one which the wells are already built in. In other words, there's no wells to be broken, as in this case with the holder. This one, you are able to actually coat it for yourselves. One of the main things that you have to take into consideration is there is letters on one side and there are numbers. So it goes A1 to 12, B1 to 12, and A to H. So you have to be specific in when you're putting your samples, and you cannot be making a mistake. So you have to have perfect concentration in where you're going to add. So now, class, I'm going to show you how to pipette 50 microliters of sample into a well. Now, it is placed as A to, so class, you're seeing A to H. So all the different wells positioning is at 1. So this one is A1, B1, C, D, E, F, G, H. All at one position, A1 position here. So we're going to be pipetting 50 microliters. So this is it's already set at 50. We're using the forward technique. So first position. Going into the well. First stop and then second. Class, we're now going to be adding 100 microliters into the same well. Same. First stop. First and then second. Now we're going to do the actual washing of the wells. Each well's capacity is 300 microliters. But in this one, we're going to do the repetitive because since we're doing it for all the wells. So we go down to the second stop. We expel 300, which is first stop. We invert, we tap, do it again. After the addition of the conjugate, after an hour, this is the reaction that we are expecting to get, which is the blue. So now we would have done we are going to do the washing technique again to wash out the unconjugated. In other words, what did not react, class. Technique again. Tap. This is repetitive. class, after the addition of the conjugate and we went through the wash procedure, we added the stop solution to the substrate. After the substrate and the stop solution, it turns yellow. So now class, we're going to go to the Eliza Reader to get our results. So class, the machine was set at 450 nanometers, which is the requirement to read. And these are the results we got. So now you will take your results and you'll plot your curve. Then you will get the results of your unknown.